DiffusionGemma, Google's new open model that doesn't write left to right. Let's see what that actually means. Before we look at DiffusionGemma itself, we need one big idea. Every chatbot you have used so far writes like a typewriter, one word after another. DiffusionGemma works more like a photographer developing a picture. The whole image appears at once, blurry at first, and then it sharpens. Let me show you what that means for text. Here is how a normal model writes. It predicts one word, commits to it, and then uses everything written so far to predict the next one. The sky is blue. Every single word is a full pass through the network, and that pass spends most of its time waiting on memory rather than doing useful math. So even a monster GPU ends up idle most of the time, producing text one tiny step after another, thousands of steps for a long answer. DiffusionGemma flips that process completely. It lays out a canvas of 256 empty slots and fills every one of them with a rough guess, all at the same time. Then it looks at the whole canvas and asks, which of these guesses am I actually sure about? The confident words get locked in place. The doubtful ones get erased and reimagined on the next pass. After a few dozen refinement passes, the noise has crystallized into a complete block of text. And notice something strange. Words do not appear in order. The end of a sentence can settle before the middle does. So, how does it decide what to keep? After every pass, the model scores its own certainty about each slot. That score is called entropy, and low entropy simply means I am sure about this one. The sampler locks in the most certain words and completely re-rolls everything else. It also starts bold and finishes careful. The temperature cools down from 0.8 to 0.4 across the passes. And here is the elegant part. When the canvas stops changing and confidence is high everywhere, generation just stops. Easy questions finish in a dozen passes. Hard ones use the full budget of 48. Now, a word about the model itself. DiffusionGemma is a mixture of experts. Think of a hospital with 128 specialists on staff. A patient never visits all of them. A router looks at each token and sends it to just the 8 most relevant experts. So while the full model carries 25 billion parameters of knowledge, only around 4 billion of them are doing work at any given moment. That is exactly the trick that lets a model this large run comfortably on a single desktop graphics card. One canvas holds 256 tokens. So what about long answers? Simple. When a canvas is fully resolved, it gets committed to the context, and a brand new canvas picks up the thought right where it left off, block after block after block. And like other modern models, DiffusionGemma can think before it speaks. It drafts its reasoning in a private scratchpad channel first, and then writes the final answer for you. Enough theory. I recorded DiffusionGemma running live on my own machine, a single RTX 4090. Watch closely, because this does not look like any chatbot you have seen. This is the actual model, running live. Notice the text doesn't type out from the left. The whole block shimmers and words harden out of the noise, while the meter climbs toward 100% settled. Roughly 100 tokens every second on a gaming GPU at home. So it is fast, and it is mesmerizing to watch, but is it actually smart? Let's look at Google's own published numbers, side by side with its conventional twin. Google compared DiffusionGemma against its conventional twin. Same size, same family, classic word-by-word generation. And the honest answer is that the diffusion model lands a few points lower almost everywhere. About 5 points lower on general knowledge, 9 points on graduate-level science, 8 on coding benchmarks. So no, diffusion has not caught up in raw intelligence yet. What you are really buying is a trade. You give up a slice of accuracy and you get several times the speed. For chat, drafting, and code completion, that is often a fantastic deal. For the very hardest reasoning, the classic model still wins. Want to try this yourself? Here is the recipe for a single 24GB GPU. And right after it, the potholes we hit so that you don't have to. 4 steps, start to finish. First, download the quantized model, 16 gigabytes instead of 50. Second, grab llama.cpp and check out the pull request that carries the diffusion sampler because it has not been merged into the main branch yet. Third, build it with CUDA support for the 4090. And fourth, run it. The one flag you really need to know is -n. It sets how many tokens the model is allowed to generate. That is the whole recipe. Your first answer appears in a few seconds. We hit 3 bumps worth telling you about. First, the obvious one. The full model weighs 50 gigabytes, and it will never fit on a 24 gigabyte card. The fix is the 16 gigabyte quantized version, which works beautifully. Second, a sneaky one. The usual 4-bit compression trick in Python silently fails on this architecture because the expert weights are packed into a shape it cannot handle. The model loads at full size and crashes. llama.cpp compresses those experts correctly. And third, our answers kept stopping at exactly 256 tokens. The fix turned out to be a single flag, -n. One caveat though, on 24 gigabytes, the practical ceiling is about 3,000 output tokens because the runtime reserves a full megabyte of memory for every single token slot. All the links are below. The model card, the quantized build, and the exact pull request with the diffusion sampler. Everything you saw today ran on one desktop GPU. Thanks for watching, and go enjoy watching some text crystallize.